Welcome, everybody. We're so glad we're back in January 2023, and it's my pleasure. My name is Elizabeth Thompson to welcome you all to the Sustainability Laboratories Conversation Series. This conversation series has been developed by the Sustainability Lab. This is our 11th session. We are using this series to make a contribution to the conversation about the urgent need to develop new models and approaches to addressing the interrelated sustainability challenges that we all are well familiar with at this point. But tonight, we're going to have a slightly different perspective on those challenges and our place in the evolution of the Earth. And it is my real privilege to introduce to you evolutionary biologist and futurist Elisabet Sahtouris. Tonight, Elisabeth has invited us to come dance with her and with Gaia. The title for tonight's conversation is Gaia's Dance, Nature's Guide to a Better World. This is the title of one of Elisabeth's more recent books, of which there are many more, and there are books, podcasts, articles, all kinds of very rich and deep information, and many ways in which to access Elisabeth's work on her website, which we will put the link in the chat for you to all access after tonight's conversation. So I'm really looking forward to this tonight, and it's with great gratitude to you and to Michael, Elisabeth, that you've joined us. And with that, I will hand things off to you, Michael.
Thank you, Elizabeth. The other Elizabeth now. Really a great pleasure to have you. You must know that you created quite a stir here that with you joining. So it's really wonderful. So let's start it. Perhaps you can introduce yourself to the audience with a kind of the professional dimension of that introduction. So please go ahead with that.
Okay. First of all, aloha, everyone, from sunny Honolulu in Hawaii. I am an evolution biologist, which I call being a deep pastist in order to be a good futurist as well. And I did make this as short as possible. I did my postdoc at the postdoctoral fellowship at the American Museum of Natural History in New York. I know some of you are New Yorkers and have been there. And I've traveled worldwide, lectured and done workshops and consulting in businesses and things on all 5 continents. I'll be celebrating my 87th birthday in a couple of days, so I've been around the block a few times. I'm a co-founder of the Worldwide Indigenous Science Network. I've devoted a lot of my energies to looking at indigenous cultures and their practices and their sciences. And let's see, I'm also an advisor to Ethical Markets, a wonderful website, the work of Hazel Henderson. And I have a chair in living economies at the World Business Academy. And you've already heard that I've done books. I've been in a lot of films and other things. So Great. Is that good enough for a professional? I don't usually do
for
this.
The beginning, yeah. As you know, incidentally, Henderson, your friend, did one of the sessions with us earlier in 21, which was really great. So the making of Elisabeth, on a personal note, about your own more personal journey, growing up, what makes you choose the field that you ended up with? What are the major milestones, shaping events in your careers, and inspiration, mentors, those kind of insights, if we can have them?
Yes, I grew up in the Hudson Valley, right on the Hudson River, about 100 miles north of the city. And I was free to roam in nature as a young child. And And I fell in love with it, of course, as any child would. You know, when you're playing with baby bunnies that are soft and cuddly, and the grown-ups are saying, don't play with them, the mother will abandon them if you touch them. And it wasn't true at all. And I knew that nature was friendly and that the moms didn't mind my playing with her babies at all. Anyway, that was the good part. And the more difficult part was that I also had a childhood with World War II because it started, Pearl Harbor was bombed on the day, when I was in the first grade in 1941. And so the war was a huge influence on my life. And as the information came out after the war, it just made me want to create justice in the world. Never again could there be a Holocaust. And so that was a very big influence in my life. And making a better world became my life's mission, right? And I did want to study science, but at that time, my parents thought science was a boys' subject and girls should do something delicate like study art. So I actually got my first degree because I was in university at age of 16. So I was still under parental influence somewhat. And I got an art degree first, and then I turned to science and went on with the master's and Ph.D. in science. And let's see, I became very interested in who are we, where did we come from, where are we headed, without knowing that those were the great philosophical questions that had been asked by some very important people in the world. It was that hunger for really understanding the human condition. How could the Holocaust have happened? Why is nature so beautiful? You know, all of these questions about who we are. And so I got interested in people's stories about how things are and the different belief systems in the world. My biggest mentors probably were Jim Lovelock, to start with, James Lovelock, who just died on his 103rd birthday a few months ago. And Jim came when I was living on Greek islands in the 1980s. Jim actually came to visit me for 10 whole days. And I recently got some letters returned to me that I had typed on vellum paper, single-spaced at the time. This is before there was even a fax machine, much less an internet or computers. And I got back a letter I had written to a friend in the U.S. about his 10-day visit to me. And I thought it was just amazing that this famous man was coming to see this girl in the woods, you know. Living on a small Greek island, you forget that you have a Ph.D., you know, especially when you're learning a new language and you're, in a way, a child again, can only speak simply to the people around you. So he was a big influence, and of course his partner in the work, Lynn Margulis, who did the microbiology while James Lovelock was developing the Gaia theory. And so they were huge influences. Other influences in my life were Thomas Berry, some of you may know, kind of the American Teilhard, and of course Teilhard de Chardin himself through his books. But I got to meet Tom and James Lovelock and the Dalai Lama. And let's see, other mentors, I would say, were Eric Jantsch with his book on the self-organizing universe. Not so well known. I don't know why he was forgotten. He was a hugely influential pioneer to me in the concept that the whole universe could be a self-organizing living system. And then J. Allen Boone, I consider my guru. His guru was a dog, and dog is God spelled backwards. J. Allen Boone's books, I hope all of you, if you don't know them already, will look at least at Kinship with All Life. It's a wonderful book about Boone's learning direct communion between a man and a dog from the dog and saying this was not man and dog in dialogue, but the universe talking us to each other. The whole concept that I came to understand as the difference between communication, which requires language, and whether it's sign language or written language or whether it's spoken language. And then there's communion, which is the direct transmission of knowledge between the tree behind me and myself, for example, or Boone and the dog. So Kinship with All Life is a wonderful book about how he learned this direct communion. And it's something that so many indigenous people have known and practiced naturally, understanding the difference between communication and communion, not confusing them. The one more big influence was Lyle Watson, and especially his book, Gifts of Unknown Things. I probably said enough about this personal journey and mentors, Michael.
But talking about unknown things, I'm not sure how many of my audience are aware of the Gaia hypothesis. So maybe you can say a few words about that. What does it mean? What is the origin? What's the significance?
Yes, well, it starts with James Lovelock in England, who was a climatologist, really probably the best climatologist I've ever met yet, along with James Hansen, whom I met later. But he was also an inventor and an atmospheric scientist who worked for NASA for years, or was at least a consultant to NASA when they were talking about Mars missions and things of that kind. And they were trying to figure out whether there could be life on Mars. And Jim, he became friends, so I call him Jim. He pointed out that you could tell from the atmosphere of a planet, and we can measure the spectrogram of the gases in atmospheres of planets at a distance, that the atmosphere would reveal whether a planet was alive or not. And so he developed this theory of, from seeing where there was no life, to understanding and wanting to understand the life of Earth, because our atmosphere is in constant reparation, if you like. It goes slightly out of balance and immediately rebalances itself, all the gases in the atmosphere. So he started to work out a kind of cybernetic model of life. And my differences with Lovelock were always that the cybernetic model was about life and the interaction of life and non-life. And I would say to him, either something is alive or not. It can't be partly alive, right? So anyway, we had a lot of interesting dialogues, and I came to understand how he had a daisy world model of showing how the living entities of life create their own conditions for life. And so for example, there's this balance between plants and animals, right? Where the one is giving off carbon dioxide that the other one needs to live, and the other one has a waste gas of oxygen, which we need to live, and the plants need our carbon dioxide and we need their oxygen. All of these wonderful ways that he worked out by hitchhiking on a ship to the Antarctic, where he was measuring the parts per million concentration of these different gases in the atmosphere with his own electron capture device, which he had invented in a kitchen laboratory. And so he was what he loved about me was that I too had abandoned academia to go out into nature and learn from it directly, right? So anyway, he was that device enabled the work of Rachel Carson to be brought to life, because now there was a way of actually measuring things like the pollutants in the atmosphere. And that started the whole environmental movement through the inventor of the Gaia hypothesis. And then James teamed up with Lynn Margulis, who was a microbiologist and who worked out how the nucleated cells in ancient times had been formed as cooperatives by bacteria, and had literally worked out something I came to call the maturation curve in science, and we'll talk more about that as we go.
So you came up with a beautiful metaphor, the dance as the metaphor for evolution, which I personally find as a holistic kind of animated perspective on reality, which I find very compelling and kind of a poetic imagery almost. I wonder if you can characterize that dance for us without getting into the detail of the different interactions, but just the notion of evolution as a dance, the imagery of it.
Yes, I got that from Lyle Watson, who pointed out that dance was the only art form where the artist is the art. Right. And that's what got my attention, because that's how Gaia is, right? Gaia is the self-organizing earth, is the dance of evolution, right? So I just thought that was a wonderful metaphor. And of course, we're taught about the mechanics of nature, the mechanism, the machinery of nature. And I said, no. It makes much more sense to see it as a self-organizing improvisational dance.
So that the notion of the dynamic, not fixed, forever changing kind of kaleidoscope of things is what comes out here. But this is really a big contrast with classical science, physics with entropy and the mechanical view of that came out Newton's mechanics, and of course in biology with Darwinism. Let's talk about this contrast for a moment, the moving from the machine to the organism.
Exactly. I spent a lot of time, especially when I had time on a Greek island to do these things, to think up these things, on the difference between mechanism and organism. And it's so interesting because, for instance, an organism, as you pointed out, can repair itself all the time. And a mechanism cannot repair itself. We talk about the evolution of computers, but what we mean is the reinvention by engineers, of generations, as we call them, of computers. So we mix these metaphors even when talking about machinery, right? And it's incorrect, because a mechanism always requires an inventor. There's an inventor behind the scene. And an organism is a self-creating entity rather than an other-creating entity. I began to call them allopoietic rather than autopoietic. Autopoiesis was a term that was coined by the South American biologists Maturana and Varela. And it was literally the definition of life as self-creation. And so I thought a lot about, the organism is self-created, the mechanism is other-created. So allo in Greek means other. So I used the word allopoiesis for mechanism, the other-created entities rather than the self-created entities, and then made lists of all the differences between them, the ability to repair while somebody else had to repair the broken machine. When you walk away from your computer, you hope it does not change while you're gone, because it's not likely to have improved itself in your absence, right? When you walk away from a friend, you hope they do keep changing while you're gone, because otherwise they wouldn't be alive, right? So this is very interesting differences between mechanism and organism. And as a biologist who had grown up with the mud of the Hudson between her toes and, in love with the trees and animals, and able to take my mind up into a tree too high to climb, so that communion was also possible. It just didn't make any sense to me at all to think of nature as a machine. But the reason that it's that way is because Western science can't understand things without measuring them and making models of them. There's a whole concept of abstraction that I never understood when I was in art school. I was told to make abstract art, and no one could ever really explain to me what that meant. In science, I found out, because to make a scientific model of, say, a brain or a tree or whatever, a living entity, you have to pull out those aspects of it which you can measure with a physical machine, a device, right? And then you put those together as a model. So you're missing a lot because you can only get at the things that you have thought up, to measure at all, and then done the measurements if you can. And so this is very interesting because abstraction literally means to lift out. So when Picasso paints a painting of Guernica, he's symbolizing war by pulling out elements of terror and weaponry and stuff and putting them into a painting. The painting is, in a sense, a model of war from his perspective. So science taught me the concept of abstraction. We make models, and we have made models over time. Think of the brain. It used to, in Freud's day, it was a plumbing system where there were valves and pipes and things got stuck in them, right? That was the Freudian model of the brain. And then we invented the telephone. And the brain became a switchboard of neurons because all these wires at which you connected the different phones, right? And then we invented computers. The computer is a brain. So the brain kind of evolved with our technology, right? As if it hadn't evolved on its own in a self-creating world of nature. Entropy.
Right. Yeah. Sorry. Go ahead.
Was one of the other things you mentioned was that the Western science physical model of the universe is an entropic universe, and then therefore an entropic planet Earth. And that means it's running down from some initial state, while syntropy, as I call it, and in science they were calling it negentropy, was their word for life, as if life, because it's not running, because it's building itself up from bacteria to us, right? It was seen as a force against the tide of entropy. That therefore negentropy was kind of a negative of a negative, because running down is negative to start with. So it's no wonder that that we built something like a consumer culture when science told us everything is going to hell in a handbasket. It's running down. Get what you can while you can became kind of the model for our current consumer culture. Party while it lasts. So this is very interesting to me, because if you look at Earth over its over 4 billion years of evolution, it has increased its complexity and its sophistication and all of, well, not sophistication, because that was already there in the bacterial world, but it has definitely increased in complexity and the harmonies that have been worked out over that time. And there is no sign of an entropic decline except for one obstreperous species who has started to wreck things, right? So in a way, humans behave entropically, perhaps because we believe in it. We have been taught to believe in it. So I have a much more holistic view of things in which I do not see this deterioration because I believe entropy to be balanced by what I call syntropy. And there's an easy way to see this if you recognize that physicists just before Einstein were talking about a smoke ring universe. Why? Because someone demonstrated in the Royal Society of Science in Scotland that if you puffed smoke into a box with a little hole and then beat on the box, little smoke rings would emerge from it, perfect toroidal forms, donut shapes of smoke in the air. And these donut shapes, this torus, Torus, is a mathematical form defined as any solid object with one hole through it somewhere. Technically, a teacup is a toroid because if it were made of soft clay, you could mold it all back in, and just the hole of the handle you can put wherever you want in the lump, right? And you and I are toroids. We have one hole going all the way through us. You know where it goes. And it's a convoluted path, but it's a single hole that goes all the way through your body. So we technically are toroids, right? So imagine the universe to be this toroidal smoke ring universe, and you're standing on top of it, you're looking down into the hole, tiny little invisible hole. Oh, there must have been some process that expanded this universe, right? We can see that it came from somewhere, and this became the Big Bang model, right? There was one point explosion miraculously happening, and everything else is this great expansion. And because we know what happens with that kind of a linear system, we know, oh, entropy, it will dissipate, it will disappear. You don't notice that underneath the donut, there's something going in order for that expansion to happen. The expansion is radiation. The inward one is gravitation. So gravitation and radiation are what needs constant rebalancing. When it gets slightly out of whack, it has to be rebalanced. That's the dance, right? So Nassim Haramein is probably the best known person today who used this model. And before him, Walter Russell and other pioneers, one in Australia, had come to the conclusion that, wow, this is not a deteriorating universe. It's not entropic. It keeps rebalancing itself, and it keeps self-creating new life forms as it does that. So that was a bit wordy, but...
that definitely a very different way of looking at things. But let's take it even a step forward, and I'll quote something that you said once, which I find beautiful and intriguing, and that is that the most exciting and beneficial thing that I believe happened to humanity in the last century was where physicists recognizing that the universe is more like a great thought than a great machine. Tell us about that thought, that great thought.
Well, that's, even Einstein recognized that concept that there's an intelligence in nature pervasively. Consciousness is somehow the beginning of the source. The source field, cosmic consciousness. The quantum scientists, of course, broke through the world of matter into what looked like consciousness. And they had no way to explain this in the Western science that they had been taught because, Western science, since it believes in a physical universe that must be measurable, anything in it must be measurable with physical instruments and to be real, could never access consciousness. And here the Western scientists, the quantum scientists, had done it. They had they had bumped into it, so to speak. And they turned to Vedic science to explain this because Vedic science saw cosmic consciousness as the source of matter, while Western science saw matter as the source of consciousness, that eventually consciousness somehow comes out of brains as they evolve. And you'll see them literally as those comic book, talk box things, whatever you call those, in textbooks. So I developed a keyboard model of the universe. One thing that all the sciences seem to agree on, quantum and standard model physics, is that the universe is somehow made of vibrations. Okay, that matter is made of vibrations is pretty much agreed. So imagine an endless keyboard going off into space, right? No end in sight. And say matter is in the low keys. And as you go up the keyboard, you get to electromagnetic energy, which was considered woo-woo stuff 100 years ago, stage shows and all that. But then they were able to measure aspects of it, so it came into the scientific world. Einstein came along and showed us that matter is energy, energy is matter, E equals mc squared. And so he could transpose music up and down that part of the keyboard between matter and energy. But matter is solid, energy is less solid, less and less solid as you go up the keyboard into mind, spirit, consciousness, right? So Western science gets stuck halfway up the keyboard because it can't measure the keyboard as it dematerializes the vibrations. And while the Eastern sciences started at the other end and derived energy and matter by slowing down the vibrations, they could see how the whole universe could be. So this is fascinating, and I became fascinated by this fact that two different sciences could look at the same universe from different perspectives and come to opposite conclusions about whether matter creates energy or energy creates matter, right? Isn't that fascinating? And as a result, when I was trained as a scientist, we actually had to take a philosophy of science course. And in it, we were taught the axioms of science. They didn't call it Western science. Science was science, right? And it's taught this way around the world. So we had to understand the basic axioms. The universe is material. The universe can be studied objectively as though you're outside it, right? Such a list of these basic statements, because you cannot make a theory in science in a vacuum. If you want to make a theory about how a universe works, you have to have some notion of what a universe is. And that's what these axioms tell you. So I actually conducted an international symposium on the foundations of science with people from all over the world, different, representing different cultures, but who had Ph.D s in what I came to call Western science, but had made the paradigm shift. We hear a lot since Thomas Kuhn's book published in the 70s about how scientific paradigms have changed over time. These fundamentals have been rewritten after you discovered, for instance, that the Earth does not the center of the universe and things like that. So I had them write out all the axioms they had been taught in what we call now Western science, and all those that they had shifted to, which turned out to be the axioms of Vedic science, just as the quantum physicists had turned to Vedic science, all of them publicly stating that they had. And then this was so fascinating that I decided to do another one on Islamic science, and I managed to get that one funded and invited like 30 Islamic scientists and philosophers of science in Kuala Lumpur in Malaysia to come together and do the same thing, to figure out what were their fundamental axioms. And interestingly, I had now a materials-based science and a consciousness-based science, and Islamic science turned out to be a living universe. Axiom number 1, Allah created the universe, as you'd expect. Axiom 2, Allah created a living universe and told us to study it. Wow. So the next one I wanted to do was Taoist science, which has my keyboard, matter, energy, spirit, and is about fitting humans into nature. But the funding for that one dried up and it never happened. And I also, because of working over 40 years now with indigenous cultures, wanted to do one or two of those on indigenous sciences. So why can we have a parliament of world religions and not a consortium of global sciences in which, say, a living science model would say, be careful in your matter-based Western science not to pollute, not to harm nature, not to harm the living world that we are part of, and have a kind of checks and balances arrangement that way.
So let's go back to the dance for a moment. The dance really takes us from atoms to galaxies, from molecules to society, from microbes and to us. And you've emphasized in much of your work that the dynamics that drives that dance has to do with interaction, collaboration, interdependencies, and so on. So could you take us through that trajectory from the beginning to where we are? How those interactions occur? How does emergence come about, and how complexification, as Chardin called it, occurs?
Right. Well, through Lynn Margulis's work, of course, I became very, very interested in the first life forms of the planet, the archaea, as they're called now, or archae-ancient bacteria. And it was fascinating because you can very simply divide evolution into kind of four billion year parts, right? The first 2 billion years, only bacteria. They had the earth to themselves. Then the next billion years, we get to nucleated cells, which turn out to be bacterial cooperatives. And then the last billion years, you have multi-celled creatures made of these nucleated cells, right? So how did the first one come about? The two greatest leaps in evolution have been the formation of the kind of body cells we have from the kind of gut bacteria that live inside us. And a wonderful scientific essayist named Lewis Thomas once quipped, maybe the ancient bacteria built us as giant taxis in which to get around safely. And the funny thing is that it's looking more and more like he was right. Because, okay, go back to the early Earth and the first bacteria that form out of, we call it in the primeval sludge. But in that primeval sludge, over 99% of the molecules in our world today were already invented. And the most fascinating thing about those ancient bacteria is that they caused 2 global crises and solved both of them. And those 2 global crises were hunger and pollution. Anyone ever heard of crises of hunger and pollution? Well, it's strange, but we are the first species since the ancient bacteria billions of years ago to face the same kinds of problems. They solved them without benefit of brain. Can we? So hunger happened because the early bacteria, the first ones made their living by fermentation and lived in near sea floor vents and probably hot springs on land and places no one else would want to live in. But they managed to. And they were so prolific that they ended up all over the shallow waters as well of the sea and land juncture places were rich with early bacterial life, which you still see in stones we call stromatolites, where layers and layers of bacterial colonies piled up and petrified. Anyway, that's how we get back to seeing how things were back then. They solved the crisis of hunger, which they had caused by eating up all the free sugars and acids molecules that were lying around on this early Earth. And so they had to invent a way to make food without such sugars and acids already formed. And they invented photosynthesis. And that was a way of making food from what was left, raw minerals, water, and sunshine. Right? And so that was a huge technological breakthrough, so to speak, in the bacterial world. And now we had not only the bubblers, the fermenters, but the blue-greens who were doing photosynthesis that had evolved out of some of them. And then the blue-greens were emitting what's the waste gas of photosynthesis? It's oxygen, right? And oxygen is a highly corrosive gas. That's what the tree behind me is giving me, is oxygen, right? And so eventually those blue-greens evolve into plants, right? The third kind then were the breathers who were able to use this waste gas of oxygen to smash food molecules. But where were these food molecules they were going to smash? The breathers were high-tech. They actually invented electrical motors that the microbiological engineers are just trying desperately to make actual mechanical ones. These things have 40 different proteins and rotors and stators, and you can see them in sperm cells, the tail, what's driving the tail on a sperm cell. Anyway, these breathers were high tech, and in order to get food molecules to smash with the oxygen, they had to drill into these big bubbler bacteria and destroy them by using their insides as resources. I came to call this bacterial colonialism, and it was nasty, right? Eventually, somehow, the hostilities turned into harmonies. This is emergence. When the bubblers, the breathers started hooking onto the outside of the bubblers so that they could push them into sunlight, and then they took the blue-greens aboard to turn that sunlight into food for the colony, and this whole thing became, each of them gave up some of the DNA, which in a bacterium is just a loose floating loop in the gel of the cell, into a central nucleus. So they stored information in this central nucleus, and that by giving up some of their DNA to it, they no longer could live independently, and this became an amazing colony. The nucleated cell, which you all know, you've seen amoebas and things like that under microscopes to see how each cell now was as complex as a large human city is in terms of all the things that happen in it. And so this was the first huge leap from bacterial cells to nucleated cells. Now, again, the competition drives a lot of creativity, even though it can be hostile and nasty. And then there is this leveling off into a cooperative situation where you have stability in a cell's life. Now, therefore, these new big cells who are living on the planet together with bacteria, they get into their own competition. And it takes another billion years before they form their cooperative, which is the second big step in evolution, and they invent the multi-celled creature. Right? Now you can fast forward because you learned all the rest about them coming out to the land and dinosaurs and flowers and, all of that stuff you learned in school. But it's the past before that that's so fascinating and that evolved through what I call the maturation curve. And if there's one principle you take away from this talk, it's that it is cheaper to feed your enemies than to kill them. It takes less energy. In our world, energy is kind of reflected in the money system. The money we spend on warfare today would easily end poverty around the world, but we're still stuck in the juvenile phase of hostile competition. And that is where we find ourselves today.
So yeah, that gets us to another thing. If you take that concept, that model with the interaction, interdependence, collaboration key to its dynamics, and you transport now to a perspective on society itself, from above so below, right? It seems that as you look at the trajectory from individual to family, community, nations, including institutionalized conglomerates that we have, there's the same pattern that repeats itself here. And show us this aspect of things.
Yes, absolutely. And what you're describing is the embeddedness of nature, which the technical term for is holarchy. the holistic arrangement of, like nested Russian dolls or onion skins, right? That things in nature are always embedded in a larger context. And so you have these holarchies of cells to organs, organ system, body in family, family in community, as you just described, all the way up to our global society now. And we've been taught a very superficial Darwinism that was adopted by our economic creators. The creators of our human economy loved the competition of Darwinism because this dog-eat-dog world, as it came to be called, was the essence of capitalism, that we are all individuals in competition with each other and may the best survive, right? Now, a lot of people nowadays are pointing out, oh, but Darwin talked about love and cooperation. He did in his last book, but he was talking about how it was the human task to bring ethics and cooperation, love into the biological world. Whereas I talk about, say, body economics. Imagine that you're doing our human economics in your body, where the heart-lung system north of the diaphragm, the northern industrial organs, are making blood by mining the blood marrow all over the body where the raw material blood cells are made, bringing them up into this northern industrial space and adding oxygen from the lungs and making a usable blood product. And suppose it then says the body price for blood is so much, and who can afford it can get it. You sell it to those who can afford to buy it. How long would you live under that kind of an economic system? You see, I have learned to use nature as my guide for everything political and economic because it's unassailable. People will not argue back with you that you are wrong because you can show them how something like that works or doesn't work, right? And this is a way of speaking truth to power without getting yourself in trouble, right? So it's very, very useful to be able to look at these holarchies and see things reflected. One of my articles is called A Tale of Cells and Cities, pointing out that when you're in an airplane looking down on a human city, it looks like a single cell, an amoeba on a slide, where you see this nuclear hub where all the downtown urban area is, and then the fields around it, and it's stretching out into the countryside to feed the whole organism, right? It looks very like a cell. And indeed, if the city has grown from a village to a town to a city in a living evolution trajectory, then it is the most viable human form of organization we have now. And a nation state is the opposite. It's completely artificial. It's scratching lines through ecosystems and saying, this is my nation. And often cutting straight through cultures as they make them, as in most of the Middle East conflicts are because of that kind of division of land into nation states. They are not as viable, and I would predict that we will lose nation states probably under the pressure of climate change when the governments can no longer function. And cities, on the other hand, don't have armies to support. They don't have to have a military budget that's breaking them, right? And they can communicate with each other and learn from each other. And we already have international organizations of mayors and cities, sister city programs, and the Rockefeller Project for 100 cities to fund them a sustainability aspect. So we are going in the right direction when we do that, when we do things like that. Superficial Darwinism misled us to the point where we don't even recognize how cooperative we are. We're told we're competitive, and we're living in cities by the millions cooperating all day, stopping at the red light, not hitting each other on the sidewalk, paying at the supermarket, you name it. It's cooperation all day. And we were so misled by the dominant cultural story of how things are that we don't even notice our own cooperative nature.
So it looks like if you take the concept that you talked about earlier about things coming together to solve a problem, basically. So here we are with this incredible perfect storm that threatens our very existence. Do you think that will create enough of a pressure to force humanity to be aware, not keep playing blind, as you say, to what's happening, and really push us to the next level of evolution?
Well, I used to think that because we have these amazing minds that can create future scenarios, that can look ahead, that can evaluate what works and what doesn't, that we would avoid coming to crises of the scope we have now. But it looks like we have to be pushed and shoved into learning by the crises themselves. And we are definitely seeing that now. We are seeing, look, the whole state of California almost underwater, and Pakistan, so much of it underwater. And so it's getting harder and harder to deny that there are changes of this massive kind happening. But one of the things that's important is to learn how to discern what's wrong in your world without judging it. And I like to use something I learned from Polynesian navigators. You mentioned the perfect storm, Michael. I often give talks called Navigating Our Perfect Storm of Crises. And I learned from these Polynesian sailors who had built canoes that were lashed together with vines, never rigidly connecting the parts, so that they could ride waves flexibly. And flexibility is one of the big things we have to learn. We're seeing more and more entrenchment in positions that are opposed to each other. And by the way, nature is profoundly conservative with things that work well and radically creative with things that don't work. And that is a 24/7 cooperative arrangement of having to do both at once, while we humans do this really stupid thing of dividing our political parties, which is good. They have the conservatives and the progressives, but to vote every year on whether we're going to follow one or the other makes no sense. We have to cooperate with them. Furthermore, when you do that, then the powers that be have the power to keep you divided, keep you thinking the other side is wrong, rather than the other side is a needed partner in keeping the world going. And those people who enjoy being the protectors should be them, while those of the things that work well, and those people who love to change things, can be on the side of here's something you have to reinvent, or right. So this is a very, very important political point that everybody should be preaching, showing why it's cheaper to feed your enemies than to kill them. It takes less energy to do that. That is how you get to maturation, to recognize that and to see how much better off everyone is. So there is no need to take down the hierarchical top-down system under which we're living now, which has become, by definition, a corporatocracy, even a fascist corporatocracy, because Mussolini defined fascism as collusion between business and big government to change the rules of the land in their favor. And that is what we have seen happening here. And you can say that word, but then use nature to back up why this is not a good way to go, right? And so the politics are also there. No cell in your body complains when there's an injured part that gets extra resources for it to heal. We understand that in a family. If one person is out of whack, it makes the whole family is out of whack. And you put some resources into that person to get them psychological help or medical, whatever is needed, right? But we don't seem to get that much beyond very local community. Whereas in the holarchy, Michael has pointed out, as above, so below, the same thing is true of our world. So we should be putting our resources not into warfare that creates more poverty and suffering, but to alleviate that poverty and suffering. So our job is to build the kinds of local communities that practice what you want in the future. The future is not something you sit and wait for. It's something we are co-creating. We're all co-creating it together. And so if you start living the way you want people to live in the future, if you eat the foods you think people should eat in the future, but give room for other people to have a different diet from yours, right? As long as everyone is fighting for healthy food production. And don't get too entrenched in your beliefs, open yourself up to dialoguing with people who have opposite beliefs, because nature never does monoculture. Monoculture is a bad human invention. And there is no monoculture anywhere in nature, not on the bleakest mountaintop or the deepest ocean. Always you'll find a lot of diversity and community. And it's from the diversity that we learn the harmonies that we need. Not what some islanders once were talking about, how where there were multiple ethnicities on the island, don't turn us into jam. Let us be a fruit salad, right? Let us keep our individual differences and put them together in something that works as a whole. So we have a lot of good examples going in the world already of people who are practicing the future now, treating people the way they should be treated in the future, working out what span of incomes should we have? What kinds of things do we want to produce or not produce? When you're stuck at the bottom of a well and you're feeling hopeless about what's going on, take your mind up high, as the Polynesian sailors would say, stand tall in your canoe when all the other signs fail you, right? Until you can see your destination. I would say look down at the human drama playing out, discern what's not working well, what is working well, stop judging it, and just figure out where is there some path that makes my heart sing to do, whether I'm a musician or a cook or a computer repair person or whatever. find somewhere that you can go into a flow with other people to help you. You don't have to do it alone. And then come back to Earth, moving in that positive direction. Optimists have a lot more fun, I'll tell you. And if you can remain optimistic in the middle of crises, you have to keep your calm, your centeredness, and you're hoping that even if the human population becomes decimated through this enormous crisis we've created, you and your loved ones could get through. If you start living the future now, you will be a co-creator of that future that you are living. So enjoy.
I think that's a wonderful moment to
enjoy up what you're doing so that other people will want to do it with you. Right?
Exactly. Elisabeth, thank you so much. This was really beyond wonderful. And thank you everyone for joining us tonight. I'm sure we'll be in touch. We'll keep that series going. This really was so exciting. Thank you so much for taking the time. Bye.
Mahalo,
and bless you.
mahalo to
Bye.
all of you.